Hi Goodies, hope you're having a good day. Today, let us continue with the prime factorization methods. In my last video, you might have gone through the factor tree method, which is used to split a number into its prime products. Today, let's discuss the second method, which is the division method, or I also like to call it as the ladder method. This is also done to split a particular number into its factors, that two prime factors. So I'm going to start with a very small example. Let me choose the number 270. Not a very big number, not a very small number. Now we need to split this number 270 into its prime factors. Okay, so let's see how to do with the division method. The division method starts by dividing the number with the lowest or smallest possible prime number. So here we are going to write 270 inside a long ladder like this. And now I am going to check with which prime number can I divide 270. So if you remember the divisibility rules, you can see that the last digit is 0. So this number can be divided by 2. It can be divided by 5. It can be divided by 10 also. But 10 is not a prime number, so let's not take that. Among 2 and 5, I am going to take 2 since it is the smallest. So let's divide 270 with 2. Don't get confused by writing like this. If you want to do the normal division, you can check by doing the normal division method. You can do the normal division of 270 divided by 2 and find the answer. And you can write the answer over here. Or there is a shortcut which I normally use. I'll start with the first digit, 2 divided by 2. Let me write the answer 1. Now the second digit, 7. 7 divided by 2, it's not possible. 7 is not there in the multiplication table of 2. So let me take the number before 7, which is there in the multiplication table of 2, which is 6. And we know that 2 multiplied by 3 is 6. So we got a 6, but actually we need 7. One extra is there. So let me give that extra 1 to this last digit and let it be a 10. So now I consider this as 10. 10 divided by 2 will be 5. Now I got my answer. You get the same 135 if you do it in the normal division way. Now let's take the second prime number 135. As you can see, the last digit is 5. So definitely it's going to be divisible by 5, which is another prime number. So let me divide it by 5. Let us do the division once again with this easy technique. Let's start with the first digit 1. I cannot divide 1 by 5. So let me take the two digits together. 13. 13 divided by 5. That also is not possible. So let me take a number lesser than 13, which is there in the multiplication table of 5. So if you check, 5 times 2 is 10, which is lesser than 13. So 5 and 2. 5 times 2 is 10, but we need 3 more to make it 13. So that extra 3 is added to this last digit 5, making it a 35. 35 divided by 5, easy, it is 7. So let's say write 7 over here. Now let's repeat. 27. Yes, you are right. 27 is there in the multiplication table of 3, which is already a prime number. So let's divide it by 3. 3 multiplied by 9 is 27. And again 9 can be divided by 3, which is again a prime number. And you will get again a 3. And finally let's divide 3 also with 3 itself. And we are getting a 1 as the last number. So we'll repeat this step until you get a 1. Now once you got this 1, you can see all these prime numbers that we wrote here will multiply to give you the original number, which means 270 is equal to 2 multiplied by 5 multiplied by 3 multiplied by 3 multiplied by 3. So you can just multiply and check, you will get the same number 270. So this method is called a division method. And I hope this was clear. Let's look into one more example. My second example is 300. So let's do the same division method for 300 and split it into the prime factors. So let us draw the same ladder. 300. If you see, the last digit is 0. So you can again divide it with any number like 2, 5 or 10. Let's avoid 10 since it's not a prime number. We can take 2 or 5. Okay. So I am going to take 2 since it's the smallest. 300 divided by 2. So dividing by 2 is very easy. You just need to make the number into its half. So either you can divide it and check, or you know that the half of 300 is 150. So let me write the answer over here, 150. Again, I can take 2 itself because the last digit is again a 0. So let me take 2. So here to start with, let me take the first digit. 1 cannot be divided by 2. So let's take the second digit also and consider it as 15. 15 is also not divisible by 2. 15 is not there in the multiplication table of 2. So let's take the very next but smaller number, that is 14. We know that 2 sevens are 14. So 2 multiplied by 7 will give you 14, and we have 1 extra to make it as 15. So let's take that extra 1 and give it to the next digit, making it a 10. Now 10 divided by 2 is 5. Now let's take the next number, 7, 5, 75. The last digit is 5. So you know that we are going to divide it with a 5. Now again let's take the first digit, 7. 7 divided by 5, not possible. So let's take the very next number lesser than 7, which is 5 itself. We know that 5 into 1 is 5. So I'll write 1 over here, and 5 plus 2 will give you 7. That extra 2 is added to this 5, making it a 25. So 25 divided by 5, 15. Now let's divide this 15. If you want, you can take same 5 itself and we'll get a 3. And finally, 3 is divided by 3 itself, giving you a 1. And this is where we stop the procedure. Now you can see the prime numbers or the prime factors which will give you the product as 300, which means I can write 300 is equal to 2 multiplied by 2 multiplied by 5 multiplied by 5 multiplied by 3. So you can multiply and check, you will get the same 300 as the original number. So I hope this method was easy and clear. So let's see in the next video. So please like my video, share and subscribe.